Hello guys, today in this video we'll be discussing about abstract factory design pattern. This pattern falls under the category of creational design pattern and is very similar to factory design pattern. Now there is very thin line difference between these two patterns and that we'll be discussing towards the end of the video, but I would highly recommend you guys to have a basic understanding of factory design pattern as well. So if you don't have a basic understanding of that, please click on the eye icon on the top right corner of the video where I have linked the previous video that I have done on factory design. So in the end, I'll also give you guys a problem statement where you can practice that, and I'll give you my GitHub repository where you can create your own branch and commit that code and in the end create a pull request. And I'll wait for 7 days, and on the seventh day, I'll make sure that I review all the pull request that comes to me. So now let's jump into the question and let's understand the problem statement that we have in hand. So I have a problem statement where I want to design a car which have some customizable parts like you have wheels, you have engine, or you have your air condition. So the car can have different options of air condition, engine, or your wheel. And there are few customizable properties as well. For example, your car life, which definitely depends on the engine that you are using and the place according to government norms. Then you have number of airbags that you can have in your car, the wheelbase that the car will have, the drive, whether it is a right hand or left hand drive, or what type of fuel it would be powered from. So these are some customization that are available in the car. Now we have different regions where we want to deliver this car to. So that means we have different areas or different countries where we have different factories for us. So we have factory in India, we have a factory in USA, and we have factory in Russia. So all these countries are totally different in their climate as well and in the government norms as well. So let's start designing and understand what are the different aspects or different values of these parameters that we have for each country or according to each fuel. So these are the customizations available. So if you see for an Indian car that is driven by petrol, the engine power has to be around 60. Now these all are very arbitrary values just taken for this example, but yeah. So an Indian petrol car has an engine which has a power of 60 around. It's a low power engine. But on the contrary, if you see Indian diesel car, it would have a medium power. So it would have a slightly more power than a petrol car in India. But if you see in the USA, the petrol car itself has medium power and the diesel car has a high power. And in Russia, both petrol and diesel car will have high powers as well. And correspondingly you can see that a number of airbags also vary, the life of the car also varies, and the type of AC, the type of tire, because based on the tropical climate in India we have summer tires, and but in Russia, because there is lot of snowing there, we have winter tires there. So the tire quality itself would be different for the same car according to the region where it has to be supplied to. So this is the basic specifications, and now we have to design a software which caters to this. So a client would want to create object for this car. Now let's start designing this and understand how you would do it without Abstract Design Factory, and how Abstract Factory would help you in having this code more reusable, readable, and extendable. So now let's start understanding the implementation that I was doing few years back before I knew design pattern. And most of you would relate to the implementation that I was doing back then. Now, over here in the code, I have created few classes or structures for the different spare parts that we have. So like air condition, we have three type of air condition: cold, hot, and both type of air condition. We have a wheel class where we say winter wheel or a summer wheel. Then again, we have an engine class where we have three type of engine, which is high power, medium power, and low power engines. So we have three type of engines, two type of wheels, and three type of air conditions as a spare part. Now, I have a create car function which takes in two arguments, the country and the fuel type. Now, based on these two parameters, there would be some logic on what type of engine power or what spare parts has to go in, right? So, as a developer, what I was doing is I was writing an code which had an if block, which was handling the country or the region. Like you can see the country logic. So, if country is equal to India or USA or Russia, and then inside each of these country, I was again writing an if block which was handling the fuel type. Now, let's say if we have a third fuel type introduced for our car, electric or CNG maybe, so we would have to go ahead and add that if block in each of these region, right? And that is very huge. Now, let's say if someday after adding the third fuel type, we also add two more countries or two more regions to our car sales. Now, this would keep adding some complexity to maintain this code, right? And this is a basically client which just requires an car object, right? Which would do some part after it receives an car object. So there is lot of logic that is written over here and lot of implementation of that logic. So every time there is new introduction to new fuel type or new region, this has to go under change. So this is not a good code, not a good code for high maintainability or scalability. Now let's start understanding the abstract design pattern and see how we can solve this problem from this code and how we can create a better scalable or maintainable code. Now, let's take a moment to understand what we have as a problem statement and what we are going to do, or how we are going to implement that or fix that problem. So, we already know that we have few spare part structures that we have created, like summer wheel, winter wheel, hot AC, cold AC, both AC, and all these spare part classes. Now, we need few car factories. So, because we have three main regions, that is India, US, and Russia. So, we have three main car factories. So, this structure that you see is factory design pattern, which you can understand in more detail by clicking on the eye icon. There I have linked that old video. So, this is creating a factory pattern where we have three factories for each region, and each factory is responsible for creating cars for that particular region. Now, if you remember from the code that we have just discussed, there had we had two different level of if blocks, so one for the country and then for the fuel. So at least that country logic has been removed. Now there we just need to define the correct factory for which country we want to create the car for, right? So at least that logic separation for fuel is gone into their respective factories. Now, because each of the factories, whether it is established in India, USA, or Russia, they need their spare parts, right? And their spare part logic is different. So, for a fuel type, petrol or diesel, the engine would vary, right? So this is why we need a spare part factory. And the only responsibility for that spare part factory would be supplying in all the spare parts that the car needs, right? So if we create that separate factory and we just give them a requirement that I need an engine for petrol fuel, right? So the responsibility for this factory would be giving the correct correct engine for that fuel, right? In India. So we would create different spare part factories as well. So I have created Indian spare part factory, USA spare part factory, and Russian spare part factory. And these factories are actually the abstract factories, right? Now let's go to the code and let's start understanding how these factories are implemented, and then how these spare part factories or the actual regional factories are implemented. So now if you see, I have created four different classes or four different files which I've opened here. And if you see, I have created an interface which is a spare part factory interface. Now this is the abstract interface for creating a spare part factory, right? It has three major functions, that is creating a wheel, creating an engine, and creating an AC. So, and while creating an engine, it would require you to tell them that what type of fuel engine that you need, right? So this is an spare part factory that abstraction of a spare part factory that we have created. Now we have three regions for our car supply. So three basic separation of your spare part factories. So Indian spare part, you have a Russian spare part factory, and you have a USA spare part factory. And each of these would implement these methods that we discussed in the contract. So if you see in the Indian spare part, we have create wheel, which would create a summer wheel, right? But if you go to the Russia, the create wheel would create a winter wheel, and USA again, it's the summer wheel. Then if you go to the create engine in India, if the fuel type is petrol, then we have a low power engine. If the fuel type is diesel, we have a medium power engine. But in Russia, in both of these cases, we have a high power engine. And in USA, we have medium and high power engine. And correspondingly, again, same with the air condition as well. So in Russia, we have a hot air condition. In India, we have both air condition where we have cold and hot both, and in USA we just have a cold air condition. So this is a spare part factory that we have created, and this is the part of abstract factory design pattern. So where we have taken the logic of creating few spare parts and integrated those logic of creating those object inside an abstract classes, right? Now, let's go to the actual regional car factory and see how these spare part factories are introduced there and how these are used there. So now I have created an contract again for our regional car factory, which is actually creating the final car product. It would assemble all those spare parts, add those few airbags, different type of wheel bases and everything. So this is the responsibility of these classes who would implement this interface. So we have just a basic method that is build car, which takes an argument that is fuel type. So it is not taking the country, right? So this interface is being implemented by three structures, that is Indian car factory, Russian car factory, and USA car factory. And all these three would implement the build car functionality. Now in build car, what we have done is we have few basic parameters which don't change based on the fuel or the spare parts being used. And these are basically those parameters that you have for that region. So for example, wheelbase in India, wheelbase would be 20 for my car. And number of airbags is in government norm where it says that it is mandatory to have four airbags. And the driving side would be right hand side in India. But on contrary, if you go to Russia, the car is left hand drive, and in USA as well, it is left hand drive cars. So we have created these basic customizable parameters. We have coded them. Now for each spare part that we want to have in our car, we use the spare part factory. So we have an initialization function for creating our factory, where we create the actual spare part factories object there in our structure. So we have a spare part factory object sitting inside our factory, and whenever we need an particular spare part, we just need to order and call the particular function for that. So we say that create and wheel. So we just call the corresponding method for from the spare part factory to get the actual spare part there. So if you see, for wheel, I've called create wheel. For engine, I've called the create engine, supplying in the fuel type, because based on the fuel, we'll get the power of the engine. Then we have air condition. So we have create air condition. Now this logic again is not recommended to be here. You can again create this logic in your spare part factory or create some other factory. That is up to you. So this is not again should not be part of this class, because again you have a logic on fuel type. But that's okay. We can keep improving and keep adding your abstraction there on these logic. But if you go to Russia, again you see the same code. But the basic difference is on the customizable properties, where you have different wheelbase, where the driver would sit while driving, number of airbags. Again, same thing in USA as well. So now the logic is based very segregated and differentiated in different classes or structures. Now let's say you one day there is an implementation where you want to add one more fuel type. So you don't have to go ahead and change your build car logic, right? You just have to go and change the spare part factory where it would implement the correct engine and it would supply in the correct engine to us. So based on that, the only changes would be in the spare part factory. It won't be inside the actual factory. So this is how we have segregated the logics of adding new fuels. So adding new fuel would not give complexity in these classes. If you want to implement one more region, you don't have to change anything in these existing region and you don't have to test them. You just create another factory for that region, another spare part factory for that region, and start implementing that. So your existing code has no effect of adding new regions on it, right? So this is how you use abstract factory. Now let's see the create car function that we had earlier. So that was a huge function. Now we just have a logic where we want to create an regional factory based on the country. So we have a factory method over here, which actually based on the country, it would give us the actual object of the factory that that we need. So Indian factory or your Russian factory or USA factory. And to that factory, we would just order to build in car, supplying in the fuel type. So now this client does not have to worry about the implementation or how that car object has to be created, right? It just have to order someone to create that car for it. And it is completely abstracted from the actual logic of creating the car. So this is the about the factory pattern, and what I would recommend you guys to go ahead and fix this code that I have over here, where I have fuel based on fuel type. I have the car life defined in each of these factories. So I want you guys to improve this code using the factory design pattern, and let's see how you guys do. And I would recommend you guys to create a separate folder for each one of you inside this abstract factory folder, and add your code there and create a pull request. I would get notified and I would see, and I would comment if there is some changes or anything that has to be improved, or if it is okay. I would merge that code inside my repository if it is in a separate folder. So please do not update this existing code there. Create a separate folder for your name and start doing it. Yeah. So I'll see you guys in the next video where we'll be understanding few more design patterns or improving our skills on the code design.